Greetings, welcome back. In this video, we will have a look at how to find R Thevenin and V Thevenin. Okay, so assuming you now know what a Thevenin circuit is, which is exactly this, assuming that you know what a Thevenin circuit is, and you know what R Thevenin and V Thevenin, what all these values are. The question comes to mind, which would be, how do I find R Thevenin from a complicated circuit? And how do I find V Thevenin from a complicated circuit? Because the whole idea of Thevenin theorem is to reduce a complicated circuit to a circuit that is easy to work with, which is exactly the circuit that you saw above there. And I'm just redrawing it here. V Thevenin, R Thevenin, and then my load resistor. This is where, well, always the current of interest, which is our load current. So how do I go about determining R Thevenin? That's why I'm making this video, to help with finding R Thevenin. So first step, if you have a complicated circuit, break it down, reduce it as much as you can to find your R Thevenin and to find your V Thevenin. Alright, so to find V Thevenin, the first thing that you need to do is, let's say, look at your circuit and evaluate your circuit. Just have a look at the circuit, evaluate the circuit, and the first thing that is very, very crucial that you need to do, if the circuit has voltage sources, let's say if there's a voltage source, short circuit your voltage sources. Voltage sources, and if they are current sources, open the circuit. This is for current, so circuit must be opened. What does it mean to short circuit? I'll show you in a minute. Say you have a conductor and you have a voltage source. Okay, let's say it's connected to a resistor. Alright, call this R1, and then maybe let's say we're finding R Thevenin. So to find R Thevenin, we say that always, if you have a voltage source, what do? You short circuit. So we'll redraw that circuit exactly as it is. However, we will short circuit the voltage source. In other words, remove the voltage source and just connect that, close the circuit with the wire. Remove the voltage source and then just close that with a wire. close it as it is, well, as I've done here. So what you have here will somehow, okay, let's say, yeah. So this is what short circuiting is. Okay, this was why I wanted to show this to you. This is what short circuiting is. It's very important that you know the difference between short circuiting. Okay, so let's say now instead of having a voltage source, we had a current source. Still the same circuit, and you're trying to find R Thevenin. Okay, current source, and we have our resistor R1. So a question would be maybe perhaps yeah, we want to find R Thevenin across a certain load resistor, which is not specified here. However, the main thing I want to show you is how to open a circuit. So to go ahead and do that, you would open the circuit. You would take out the source, look at the current source, take it out and throw it away. And your new circuit will look like this. So this is opening the circuit, okay? Leave it open like that. So every time you have a current source and you want to find R Thevenin or your Thevenin resistor, if there's a current source, you remove it and you leave the circuit open. If there's a voltage source, you short circuit it. Okay? Cool. That's very, very important. Okay, and what about Thevenin? Okay, to find your Thevenin voltage for Thevenin, what you do is you bring back the circuit as it is. Pardon me. With Thevenin, you would consider the circuit as it is, with all the sources as they are, the voltage sources, the current sources, and then just go ahead and reduce your circuit as necessary, and then eventually measure or read out, evaluate your open circuit voltage. Things will make more sense once we start doing application. One important thing for Thevenin resistor, for the Thevenin resistance is that I forgot to mention is that the Thevenin resistor or resistance is the resistance that you get, or the is the equivalent resistance that one would get after reducing the entire circuit into a single equivalent resistor. Well, I mean after reducing after combining all your resistors into one resistor. What do I mean by that? I mean, say we had 3 resistors in this circuit, R1, R2, R3. So the equivalent or combined resistor of all these would be R3 plus R2 plus R1, and all these, the result that you get, that is your R-Thevenin core. Thanks for watching. Application would make more sense when you start doing application. I'm sure some of these things would make a lot more sense than